For 12.1, we are going to learn about rational numbers. So we've learned about integers. So integers are the positive and negative whole numbers. So the step farther than that is a rational number. Now this definition is going to be a little bit confusing, but we'll break it down, okay? So a rational number, we're going to define it, is written in the form A over B. So it's a fraction, is what that's saying. A and B are integers, so they're whole numbers, so you can't have 1.5 over 2, right? You can't have a decimal and a fraction together. So these are both just whole numbers to make a fraction, and B cannot equal 0. So you can't have 4 over 0 is what that's saying. So you could have 3 over 4, 7 over 8, 9 over 5. You can even have an improper fraction, but these are integers here. So it's really just a fraction is what we're talking about. So if you're confused, that's okay. That was kind of a weird definition. And pretty much it's a fraction, or it can be written as a decimal number that has an end to it. So anything that can end as a decimal. So if you had 3/4 as a fraction, you can simplify that to 0.75. That's 3/4, 75 cents. And it ends, it has a decimal and an ending spot. So if you have a decimal like 0.72536942839 and it just keeps going, right? That doesn't have an end. That's not a rational number. So a rational number is just one step farther from the integer, the whole numbers. Now we're including decimals and fractions that are nice ending decimals. So make sure you have filled in those sections there. So let's talk about some examples of rational numbers. So 0.35, 35 hundredths. It's a decimal and it ends, okay? I could write that as a fraction as well. This equals 35 over 100. So here we have 6. So that is an integer, but we could also write it as a fraction, 6 over 1. 6 divided by 1 is 6. So whole numbers can also be rational numbers. So we're just expanding from integers to now include fractions and decimals. So some other examples, 4/5. It's already written as a fraction. I can change it to a decimal and that equals 0.8. It ends, the decimal ends. Or here's another example, 8 and 942 thousandths. So I can write this as a fraction, 8 and 942 out of 1,000. So those are all examples of rational numbers. So it's just we're including decimals and fractions now. So we're going to draw a rational number. So we have 3/4, and I know that equals 0.75. I have 75% of this, so we're going to go ahead and just shade in 3/4. So just there's another example of a rational number. A fraction is a rational number. When it can be written as a decimal that ends, it's a rational number. Okay, so next up we have this section here. So if we look between 0 to 1, so from here to here, there are how many lines between there? So I guess there's how many spaces between there, right? So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 lines here. So that means every single one of these, if we break up 1 into 10 pieces, each one of those spaces represents a tenth. So we're talking about fractions and tenths or decimals, tenths. So we're going to graph -2.6, right? 6/10. So we have to go backwards to -2. So here's -1, -2, and we've got to go back to -2. Here's -2.5, right? Here's -2.1, -2.2, -2.3, -2.4, -2.5, -2.6. So right here, we graphed 2.6. So make sure you graph that on yours. So now we're going to decide where is negative 2.6 between. So it is between which integers? So remember, integers are whole numbers. So if I go, here's the closest whole number. It's between negative 2, and the other one going the other way is between negative 3. So the integers it's between are negative 2 and negative 3. And we know that it is to the blank of 0. Here's 0. It is to the left of 0. So we're just trying to figure out where it goes. So it was between negative 2 and negative 3. And we know we had to go to the left. So now we're going to solve a few of these inequalities with rational numbers. So we're going to write that inequality, right, are not equal, so our comparing symbols. So we have negative 1.8. So right, if I go negative 1, here's negative 1.5, 6, 7, 8. It'd be right here. And if I have negative 3.4, it's got to go all the way over here. 1, 2, 3, negative 3.1, 3.2, 3.3, 3.4. So I can see this one is more to the left. So this one right here is bigger. I feel like I'm missing my pen. There's my pen. There we go. So negative 1.8 is greater than negative 3.4. I can read that backwards. Negative 3.4 is less than negative 1.8, right? This person has less money. They owe somebody more money than this person. Okay, now we have some fractions we're going to compare. So we have 3, 6. So I'm going to think about, what do I know about 3 and 6? And I can simplify that. 3 and 6 can both be divided by 3. 3 is their greatest common factor. 3 divided by 3 is 1, and 6 divided by 3 is 2. This is the same thing as 1/2. Now thinking about this one, right? If I have 1/2 here, maybe I can draw myself a picture. So here's 1/2. So if I have that same circle here, this is only 1/4. This is a quarter. It would be about right here. And this one is right, 1/2 is right here. So I can see a half is bigger. So we have lots of strategies we can use. We can simplify. I could even turn this into common denominators. So I know this one is a 4th. I could turn this one into 4. How do I get from 2 to 4? I times it by 2. So 1 times 2 is 2. Oh, 2/4 is greater than 1/4. All of these are the same, right? Half of 4 is 2. Half of 2 is 1. Half of 6 is 3. So those are all equivalent fractions, or this one is just 1/4. So 3/6 is greater than 1/4, or we can read it backwards. 1/4 is less than 3/6. So pictures, common denominators, your number line, all of those are great strategies to use to compare those rational numbers. All right, and our last one we have here is negative 1.75. So that's $1.75, and it's negative. So I know it's got to go this direction. So here's 1, here's 1.5, 1.6, 1.7, here's 1.8. So it's right here in the middle. It's really close to 1.8, right? $1.80. Just right to the right of that. Now we also have negative 1 and an 1/8. So if I'm thinking about this one here, I'm going to turn that into a fraction first. So we have negative 1 and 75 out of 100. So we have quite a bit of that here. This one we only have 1 out of 8 pieces. So let's turn that into 100. So we're going to think, how do I get from 8 to 100? So if I'm not sure, I'm going to divide that up. So 8 divided by 100, that goes in there one time. and 2 left over, and that's going to go in there 2 times. So about 12 times. So about 12. So about 12. So we're going to do 1 times 12. So this is only 12 hundredths. This one's 75. So 75 is bigger than 12, but because they're negatives, this one is only going to be right over here. So this one right here is more to the right, and right is bigger. When we go to the right, we're bigger, so right is bigger. So here we have -1 1/8 is greater than -1.75. I can read it forward as well. -1.75 is less than -1 1/8. So thinking about where the rational numbers are on the number line, thinking about common denominators and simplifying things can really help us compare those rational numbers to see what is greater and what is smaller. Okay, so take no more than 5 minutes, color anything important. So maybe the title, maybe your graph, making sure you really can see where that -2.6 was to connect that there. So no more than 5 minutes, color that in.